All right, is Bun better than Go? What the heck is this?
Well, Bun performed in the previous benchmark, so I decided to compare it with Golang. In my mind, Go is a different class compared to JavaScript. In this video, we'll first compare Bun with Golang using standard library. We'll use /API/devices endpoint to return a hard-coded device in JSON format to the client, and we'll focus on 4 golden signals. Since these are user-facing applications, our main focus will be on latency, specifically using P99 percentile.
For those that don't know, the difference between these things is that Bun obviously runs JavaScript, all right? Go is its own language. The reason why JavaScript should never, ever, for any reason, be faster than Go is because at some point there's something called V8, which has to take in text, turn it into bytecode. Then it has to keep track of that bytecode with some sort of like optimizing stuff. You'll see this if you look at the memory usage. You'll see that the memory usage goes off the charts on a per function basis for how much memory is actually used. And then on top of that, if it's called enough times, depending on the length of the function, typically, at least in V8, it will go off and then it'll actually try to JIT it. So if it's called with enough times with these similar shaped objects, it will then do a proper thing. Now, obviously, Bun uses JavaScript core, so I don't know if the rules are or are not the same, but there's something, right? And so just-in-time compilation is going to have something that produces something like some sort of assembly level performance. I'm not exactly sure the exact nature of it, but I know that it's not going to be as fast as something that is compiled and as good. I've heard numbers saying it's twice as slow as your standard program language. I'm not sure if that's true. It's ass performance. That's all I know. So Go, as long as there's not some sort of egregious programming issue, Go should massively outperform. Because remember, every time these functions are called, they're still tracking a lot of information. So it's not completely for free, right? There still is this optimized thing going on in which, goes and determines, are we still jitting or do we need to unjit it due to the type of arguments being passed in? All sorts of stuff.
Next is throughput, which for web application means the number of requests per second that each application can handle. Then we'll look at saturation by measuring how full the service is.
I also just did a test on this, when Bun came out. And when I did it, Go was like 2.5, 4 times as fast, something like that. I can't remember. It was significantly faster for the exact same thing.
More specifically, CPU and memory usage of the applications relative to the limits defined in Kubernetes. We'll also need to measure CPU throttling, as it plays a significant role in Kubernetes. When a service is throttled, it immediately increases latency and degrades overall performance. Finally, we'll measure availability by looking at the number of failed requests relative to the total number of requests over a specific period of time. Now, most benchmarks focus on synthetic tests, but I also want to see how these applications perform in real-world scenarios. I use different use cases in different benchmarks. In this one, we'll add a persistence layer using MongoDB database. Every time application receives a post request, it will parse the request body, generate UUID, and save the item into MongoDB. In addition to standard metrics, I instrumented each application.
I mean, this still isn't very fair. Like, this is just not a very fair thing. There's just so much more crap that goes on. Think about just the size of your headers in these synthetic tests. The size of your headers alone are rather small. They're not going to contain all the data that you would in the real world. And so it's just like, there's just so much smaller things. gRPC solves this. Well, yeah, gRPC uses HPAC, which HPAC is going to effectively greatly reduce your header size. No, my headers are huge. I know your headers are huge. That's the problem. If you're not on HTTP2, which most of the internet now is on HTTP2, you're going to have huge header problems. If you're at least on HTTP2, you won't have that header issue. So, or at least you won't mostly have that header issue.
application with Prometheus metrics to measure how long it takes for each application
I don't know the difference between
to save
HTTP3 and
a device
HTTP2
to
headers.
the
I know it's
database.
QPAC versus HPAC. I've
Additionally,
never gone over
someone
the QPAC
suggested
algorithm.
including database metrics, so I have also added CPU usage of MongoDB itself. And in these tests, we'll generate enough load to find the breaking point of both applications. I deploy both applications to production-ready Kubernetes cluster in AWS using large instances for the applications, each with 2 CPUs and 8 GB of memory. Since Bun uses a single thread for most operations, I limit each application to 1 CPU, which can be viewed as 100% of a 100 millisecond interval in a cycle that repeats indefinitely and enforced by cgroups. Additionally, I allocate 256 MB of memory. I also scale applications horizontally, deploying 2 instances of each application on each EC2 instance. To generate load, I use Graviton instances, which are a bit cheaper, and deploy 20 pods for each application. These pods gradually increase the number of virtual clients until both applications fail. Any advice on how to improve either?
By the way, good that he's using real machines, not using localhost. Localhost can be kind of deceiving. There's a lot of optimizations that do localhost type of performance tests, so I always am very wary of anything that involves, or weary of anything that involves localhost. Taking away Go's performance benefit by fitting the test to Bun's. Yeah, you're also, yes. Okay, so that's a really good point, which is one thing that's deeply unfair about all of this is that for those that don't know anything about how JavaScript works or any of these runtimes work, the runtime is the environment in which JavaScript runs. JavaScript is actually not, is not the full thing. There's also all the network stuff. And so this can technically operate on many threads, but this cannot operate on many threads. The JavaScript itself has to be executed on a single thread. And so you can go through here and you can aggregate your requests. Every one of the requests that come in can be parsed and operated on and then put onto the process queue. And so that way they're answered in order and all that good stuff, right? Awesome. But the actual popping of the process queue is going to happen in order and on a single thread. Whereas with Go, you don't have to have this. Go can answer these things in a very, very kind of a multi-threaded approach with how they do their Go routines, which is fantastic and allows for actually significant speedups. So whoever said that is absolutely right. This is something I just didn't even read. They took these. You really completely dominate your ability with Go by simply taking it and saying, oh, you only get 1 CPU. Because the reality is this. It's extremely easy to vertically scale Node. And so Go routines allow you to just simply go, oh, I have 4 CPUs, I have 8 CPUs, boom, right? It is pretty amazing what you can do. Node is not single-threaded. Yes, because Node is the runtime. So, as I described earlier, Node is the runtime, or Bun is the runtime. JavaScript Core, or V8, is the JavaScript engine. The JavaScript engine is required to be single-threaded. When you're running JavaScript, that is single-threaded. You cannot add and remove items within it on anything but single-threaded. Now, even garbage collection is largely done off-thread. There's these scavenger tasks that happen off-thread. But there isn't anything, it's only, the actual JavaScript running. Promises are multi-threaded. No, they're not. They're not. Okay, they're not multi-threaded. If you think they're multi-threaded, don't worry, Nightshade, dude. You don't have to worry at all. Promises are not multi-threaded. You just don't understand it. Okay? That's not how this works. What happens underneath the hood on a promise could be multi-threaded. And that makes sense. Promises themselves are not multi-threaded. There's an event loop, and every single thing gets added to the event loop. That's how these things work. Promise.all is... That's concurrency. Okay, so here. I didn't realize how much people have no idea. First off, y'all need to understand, you need to understand some pretty basic stuff, all right? So let's pretend we have 3 network requests, and we do a promise.all, all right? Now, the constructor to the promise, each constructor will execute in order. So let's pretend this is how long the constructor takes. This is how long the network request takes, and this is how long the processing of the result takes. That means if you executed 3 of these in a row, and let's just say they all take, they're going to take, here, I'm just going to draw this nice and carefully. They're all effectively executed what appears to be in order. Promise.all, here's an array. This does not execute. It has to wait for the ability to have the thread. And so now that the constructor has executed, the network request is out, then the next constructor can execute. Now it's waiting on the network, it's waiting on the networks and some sort of processing at the end. Now, when this network comes back, it will have its ability to execute. Now, here's the best part, is if this one came back down here, it would actually have to wait until it has the ability to execute. So that means this thing is going to be waiting until it has the ability to construct. Does that make sense? JavaScript executes always synchronously. Go does not have to do that. This is in fact incorrect. Anytime JavaScript is executing, it is single-threaded. There is no difference ever at any point. Well, I just explained it, that it can't be. And he's like, no, actually it is. It's in the kernel. No, it's not. You got to listen to the words. JavaScript can only execute single-threaded. Now, underneath, it can be multi-threaded. You're absolutely right. Network requests can go off. And if there's C++ that processes it, it can be processed. The headers can be decoded. All those things exist. But JavaScript itself is single-threaded. Workers are they're a new V8 isolate, right? So underneath, yes, things can be processed. But on top, they cannot be. Okay, so now that we all know this, you just gotta go read. Okay, you have to go read, and you gotta go look. Yes, the runtime can be multi-threaded. Absolutely. So that's why this is a very unfair test, because Golang, if you did this with Go routines, would look more like this. Each one of these would be a constructor, assuming they're all taking equal time, of course. And this would be the 3 processes on the other side, right? They would all happen in parallel with each other. If you did go func, go func, go func. Theoretically, if you had all the CPU, there's obviously some, there is some level of complexity being hidden here. But assuming you had all the processing power in the world, you would be able to do that. Right, go funk yourself, exactly.
Application is welcome, as well as pull requests, which I typically merge within a single day.
Sorry for
All right.
Sorry for calling you stupid. Sorry. My fault. I got a little intense there. My fault on that one, okay? I'm gonna say my fault on that one, okay? I got a little excitable. A bunch of people keep saying they're less than 13 years old or calling themselves 13. I've had to ban too many people today, and so I'm just a little riled up, okay?
Right, let's get started. In the first test, we evaluating how well each application can process HTTP requests and return hard-coded values in JSON format to the client. On the top right graph, we'll measure throughout.
I forgot to say, this is the reason why this is unfair to Go is now you're giving 1 CPU. So if you only give 1 CPU, the thing that makes Go so amazing is that it does this. And so by this working fast with Go, right, it's just like you've now defeated one of Go's best things, which is exceptionally simple vertical scaling.
Output, which shows how many requests each application can handle. On the left-hand side, we have latency, which measures how long it takes to respond. From the start, you can see that one application takes significantly more time to process each request. It's also important to note that we measure latency from the client side to make it as accurate as possible. Next, we'll look at saturation, which indicates how full the service is. You can see a trend in CPU usage. Go uses more CPU time and will be the first to experience throttling. Since I deployed 2 replicas for each application, we're measuring average CPU usage. On the right-hand side, we have memory usage, which only becomes critical when both services are overloaded. Next, we have...
I think this is a good thing, Go using a lot of CPU. It means it's more efficiently using the small amount of allocated CPU that you've been given. I'm having a hard time understanding why this isn't good. The hard part is the requests per second are about the same, which something is going weird here. Memory usage is way down, CPU throttling not there, availability all the way right here. Why is more CPU being used? There's less whatever this throttling is. I'd have to understand more about this. Something feels...
Availability. In this test, the average request takes less than 1 millisecond to complete, so I set the client timeout to 100 milliseconds. When that timeout is exceeded, you'll see a drop in availability graph. Up until 60 to 70% CPU usage, you won't see any throttling. At around 23,000 requests per second, CPU usage differences between two applications become more apparent. By this point, Golang starts losing its advantage in latency. For this type of application, once CPU usage hits 40%, performance starts to degrade and latency increases. By around 40%.
Something has to be wrong, and it should be a dead giveaway, because Go is a compiled language. Like, if it is one for one, something goofy is going on here. What is it? Go still could be very fast on a single CPU. The standard lib just does a Go routine for every request and not a worker pool. So this kind of test is targeting a specific weakness in the standard lib and forcing thrashing behavior. This is not a language itself. Yeah, I feel somewhat confused by this. The language that can use multi-call properly will have schedulers that distribute at work, which must have some overhead. Yeah, but I guess one could argue that the scheduling mechanism is more difficult on a single CPU for Go than it is for Bun if it's just an event loop, right? Bun is just simply adding tasks to a linked list. So you can just go, it's like an O of one operation. Whereas when you have a scheduling and Go routines, you're probably not doing well. Maybe that's the issue that we're seeing. It's just weird to impose JS limits on Go. I'm very confused by this.
6,000 requests per second, Golang starts failing behind Bun in terms of number of requests it can handle. At 61,000 requests per second, the differences becomes even more noticeable. Golang's latency increases to 10 milliseconds and Kubernetes begins throttle it, which affects performance. On the other hand, Bun maintains low latency, although some requests start to time out. It's not many, but you'll notice drops in availability graph. At 69,000 requests per second, it becomes clear that Golang can't handle any more requests and begins caching some of them. Alright, let's continue. At around 90,000 requests per second, Bun also hits its limit and gets throttled by Kubernetes. Now, let me open each graph for the full test duration. As you can see, the test took around 2 hours to complete. First, we have requests per second.
Yeah, I am very curious what happens as you increase CPU allowance and all that. Perhaps, I guess the only plausible explanation has to be that the scheduler is very bad when you give it exceptionally limited resources, which is actually a pretty reasonable argument. Hey, why have a complex piece of scheduling that is meant to vertically scale on something that has absolutely no benefit? But something still feels very fishy about that. There could also be some magic zig optimization, but the magic zig optimization should be also quote-unquote magically available.
Next,
also
client latency. After Golang starts...
It should be also available in Go, right? There's not some sort of magic thing. Bun's HTTP implementation is written in Zig. So they're only JSON stringify that's run by JS. Oh, okay. So they're doing... Are they doing the entire thing in effectively they're just only using Zig utilities? Yeah, because Zig should outperform Go by a good margin. Just because they can do all sorts of really impressive things with Zig. You can do arena allocations. Yeah, this is one of the problems about when I say small world tests. I would actually let's see if we can look at the code. Small world tests are one of those very interesting worlds that exist, original source code. The reason being is that you have this really tiny amount of JavaScript that gets executed, but it doesn't look like that, app.js. Yeah, it's not just simply that. So I am curious why this thing is performing so much better. There's this histogram thing. They're doing a string check. They're creating UUIDs. They're doing a JSON. The JSON's obviously done well. I wonder what is going on. It's very interesting, right? It's only calling get. Oh, it's only calling get. It's not creating any new devices, so it's just doing a get and doing this. Yeah, but it's still doing something, right? Healths with a Z. Very awesome. Very good. TypeScript master race. If bun is better, then you should use bun. Right? That's the reality, is if bun is better, you should use bun. Because I mean at the end of the day, whatever is really great, or let's try to replicate the results. No, I don't want to replicate the results. Huh. What is Prometheus? It's obviously some sort of I don't know. I don't know what this is. This is something I don't know what this is, but this is writing to Prometheus directly from Go. Yeah, we're writing to Prometheus. Maybe I missed the Prometheus part. Prometheus is a time series DB. Oh, nice. Okay. Where's main? App.js. Yeah, this one you don't see any. At least you don't see the time series DB here. But I'm sure it does exist. I'm sure. Obviously, I must be missing some sort of something that's going on with the post. Register from prom client. Oh, there we go. Register. Nice. Okay. Yeah, that's only on a metrics call. So that's on a metrics call. So there must be some sort of thing that's going on that's able to do all that. There must be some sort of middleware, one would assume. If bun is that fast, then use Zig. Yeah, Zig is really, really good.
Degrading at around 40% CPU usage, its latency surpasses bun's. But before that, its latency was much lower.
If Zig is so fast, just use C. Well, Zig is just really convenient C.
Next, we have CPU usage.
I'd be really curious. Yeah, now the desire to know what has happened
Then,
is entirely too high.
You can see memory spikes in Golang when it's unable to process all the requests and starts caching
I'm not
them.
getting nerd snipes.
Eventually, memory usage reaches 100% and Kubernetes kills application multiple times due to out-of-memory errors. After that, we have availability graph.
I did. I looked at the code.
Finally,
I
we have
already looked
CPU
at just
throttling.
The main
If
looks
you're
close
building
enough.
client-facing applications where latency is important, you may want to consider Golang because up until 40% CPU usage, it performs much better. On the other hand, if you care more about throughput and latency is less critical, such as internal microservice, bun might be the better choice.
I don't think you can take any takeaways from this because, again, you're literally just like hard coding a single device. Like no endpoint has ever looked like that, right? Don't make decisions on this. You'd want something that's a bit more complete because typically you're making several requests within inside of any other request. You're doing a bunch of stuff and then aggregating all the results and then doing something. A single JSON stringify, I don't know, Copium could very well be Copium. Just something about this doesn't feel quite correct.
Test. Most benchmarks use simple tasks and algorithms to measure performance, but in reality, you would rely heavily on external libraries, and your application performance would depend on how well those libraries developed. Also, almost all applications require some kind of persistence layer, such as a database. In the previous bun versus Node.js benchmark, I used Postgres relational database. In this test, I have replaced it with a MongoDB document database. If you're interested in how bun performed with Postgres, you can check out that video. I instrumented both applications with Prometheus metrics, so we can measure the duration of each function call.
Nice.
In this test, when application receives a post request, it generates UUID and stores the complete object in the database. You can find a link to the source code in the video description. I also use Prometheus histogram to measure how long it takes to insert data into MongoDB. Additionally, based on feedback I received, I'm now measuring Mongo CPU usage along with the other standard metrics. In this test, Golang performs significantly better than bun. The latency for both the client and database insert is almost half of what bun has. Golang also has much lower CPU usage compared to bun. At around 7,500 requests per second, bun starts to degrade and drops some requests. Kubernetes also begins.
I still think it would be still much more interesting to see more work done in endpoint. you have to have more work. Like, I want to see an actual representation. Like, the problem is the last time I've done any sort of testing, I built a game that's played completely on the server to test the difference between Bun and Go, and the results were staggeringly different. It doesn't really feel that much more wild when you don't run with like an actual, actual goodness versus just like, hey, here's a simple program that does one thing. Most endpoints aren't as simple as I take it. Like, I mean, hopefully you're not writing something as simple as a CRUD endpoint that's like store device. It just comes in, stores a device, and returns, right? You usually have a bit more stuff going on than just simply one-for-one database operation per actual request going in and out.
Throttle it, which causes the latency to increase.
Because I'm not
Let's
sure if I can even believe this
find
test.
Golang's breaking point.
Right.
At around 24,000 requests per second, Golang starts to degrade as well, reaching nearly 100% CPU usage. As you can see, when the test involves more than just returning static responses like in the previous test, Golang performs much better. In real-world scenarios, you will definitely need more than just static responses. Based on my experience and benchmarks I've run, Bun performs very well with static synthetic benchmarks, but when it's time to do real work, such as interacting with a database, Bun loses many of its advantages. Even Node.js performs better in these cases.
That would be more curious than anything else. Because that's actually a real test. I think Aiden said it. Aiden, amazing Go engineer at Twitch, even said if we're going to agree that Bun is better than Go, then we also need to agree that Postgres is better than React, which is just a wild one. Now, if Node.js actually does outperform Bun, at least we're comparing a very similar environment, right? We're comparing two environments that have effectively the same conditions. Now we're comparing legacy C++ plus a bunch of if-defs plus all this stuff, plus V8 versus Zig, none of the legacy, JSC. Now, classic Aiden base take, right? Just why is he so based? Just based as it gets, right? This Aiden guy sounds smart. This Aiden guy sounds like he's pretty good looking too, huh? All right. But I think Antediluvian Apocalypse, I don't know where you went, but you said something that I think is probably the best, which is most of us don't write code that executes with 90,000 requests per second on a single machine, and you're also only running the world's tiniest amount of CPU, right? You're going to probably scale up and use a lot more CPU. But regardless of all that, you're going to probably do a lot more work. You will not even be close to being able to perform that amount of operations per second anyways, either in Go or in Bun. But on top of that, you should probably just choose the language that makes you more happy. If you can just choose the language that makes you feel more productive and feel more excited, you are likely going to be a lot happier. You just will be. You'll be a lot more happier than if you choose a language just for efficiency and you hate it. Right? Like, I just don't find a lot of love in Rust. That's all there is to it. I just don't find a lot of love in Rust. I'm willing to re-give another Rust attempt where I attempt to make sweet love with Rust one more time, but I just don't like it. It's not fun for me. I don't get languages that are really difficult. Languages that are really difficult to refactor, or when anything changes that I have to do a lot of like changing. I find that to be very frustrating. Zig doesn't seem to have that problem, and Go does not have that problem, whereas Rust does have that problem. And I just don't like that. What the fuck is a boxed pointer? It's not that bad. A boxed pointer is just it's just a pointer. Okay, that's all it is. They just use the term box, right? Because you have to have something that's consistently sized on the stack. And typically, whenever you're like using JavaScript, they call it a boxed value as well. A box is just a pointer. That's all it is. It's just something. Yep, dick in a box. No, it's not a dick in a box. There's no dick in any box. Okay. What is an arc? That's an atomic reference count pointer. Okay, it's a shared pointer. If you've ever used C++ and you use shared pointer, that's all an arc is. That's it. That's it. A bic and a docs. Yeah, that's right. Too many types. Changeability is important to software development. That's typically why I enjoy Go or Zig more, just because I find that the changeability is rather nice in either of them, typically speaking.
I suggest testing your specific use case before choosing Bun if your goal is to improve performance. Alright, let me show each graph for the entire test duration.
All right, nice. I still don't really consider this I don't really think this is a big win for Go either, and I'm not sure if this is any sort of issue here. Like, you can see right here that you've effectively just maxed out. I mean, you can see right here that Mongo becomes the problem. The database insert is where we're actually stuck in all performance. Just by looking at this graph, one could guess that that's just the problem, is you're just playing database insert, because you'll notice that this matches that, right? And so it's not like there's not a lot of huge W going on here. I'm a little confused why there's so much lag right away with Bun and inserting into the database. To me, this already says there's something wrong right here that has nothing to do with whatever's going on, whatever we're seeing, because you'll notice that this and this are almost 1 for 1, right? Your entire latency is dependent on how long it takes for you to insert into the database. And a 20 millisecond insert just feels like something's gone wrong. Yeah, there's something, yeah, exactly. There's just some other thing happening here that we're measuring that's not quite the right thing. It's just, you're measuring the wrong item. And my guess, again, is just the fact that it has to do with exceptionally tiny amount of CPU that you have allotted to this machine. And just you're having all these different things vying for attention. So it's just tons of context switching. If you have a connection pool to a MongoDB that's spawning a bunch of these little green threads running, and then on top of it, you have a whole bunch of, every single time you make a request, you add something to the process queue, in which then adds a couple more things to the process queue. It's just then you're getting this ever-growing thing here, and then you have Go that's constantly running, right? One core is for Bun, for Bun is also rough. Yeah, one core for anything is typically rough. When it comes to JavaScript, you usually do n-1, because you want at least one more core for all the other things running. But just having everything on one CPU that's also been limited, you're just not going to win, right? There's no W there. There's no W going on here. More CPU would, yeah. And the reality is that if you just added a CPU or added 2 CPUs, Bun's performance would likely increase by a significant margin. It's n-1. N-1 is how many Bun instances you want, right? But Go's performance would not increase just significant. It would increase like astronomically. It would just be pegged right to MongoDB's ability to insert on a single machine. That's it. Like that would be Go's performance, because Go would be able to utilize all the available other CPU very, very well.
First, we have requests per second.
Yes, and also what would be really, really nice is this right here. Being able to run several Bun instances, or however you want to do it, to be able to run multi-thread Bun, whether you're using workers or several instances, however you want to do it, then do that. But you also have to describe that as a difficulty, because let's just be at least a touch honest here. Having a singular program, right, foo, that runs and is able to utilize all of your CPU cores no matter what you're using is significantly easier to write and to maintain than writing some service that has to thus spawn some n-some number that you've determined works correctly for the amount of cores that are available on the machine, such that you can make Bun run as efficiently as possible, right? Like, this is a problem that you don't even have to think about. This is a problem that you have to think about, and you have to write correctly. You have to write some sort of reverse proxy for all the instances to be able to hand that out, which means you're probably not writing Bun to begin with, because now you're writing a reverse proxy probably in Rust or in Go or in Zig. Like, you just have this entire other problem that exists that you just don't have here. And that's engineering hours. This is engineering hours.
Second graph.
That's pretty awesome, though. So it's not free. I just wanted to, I'm sure there's a lot of really great stuff, by the way, that you can do that will make it work. Because someone said Bun has pretty simple clustering with shared port. Yeah, I'm sure it has something that's already been built in. It probably already has, it must have the reverse proxy already built in for you. But nonetheless, you're still having to write the reverse proxy. You're still having to think about that as a problem, right? Hold on. I got something. I'm going to be right back. Flip, take this out.
Client latency.
That's kind of fun, this little curve.
Database insert latency.
Multiple CPUs wouldn't really help. Let's see. Wouldn't really help with Go that much, just push this behavior out a little bit more. Well, it would help in the sense that it pushes that behavior out more. I mean, obviously, you'd be pegged to your database at some point, but it would most certainly help a decent amount because Go can, you don't even have to think about it. Go just naturally will use all of your CPUs significantly easier. And so if you added a couple CPUs, it would nicely use all of that, and you wouldn't even have to think about it. Now, obviously, your CPU or however Mongo's been written, I don't know. It's the unbounded number of Go routines versus workers. Yeah, but there's a lot more overhead when it comes to a worker in Bun than there is in Go. A Go routine is a pretty lightweight construction. A worker or a new Bun instance is a heavyweight item. To be able to have several buns running, you're going to have gigabytes and gigabytes of RAM. Whereas if you don't have that, it's just there's going to be a lot of different. There's definitely going to be some things here. It's okay, but I'm heavyweight too. Yeah, it's okay. You can be heavyweight. We're not even saying that. Even again, just go back to what I said at the beginning, which is honestly, if you'd rather write Bun, go for it. Enjoy your several buns. Okay, that's for you. It's just not a problem I enjoy. I've actually found that a really simple language has allowed me to have a really simple model of the world, which has allowed me to really think about the problem I want to solve. And yes, I would assume that the Go standard library does a coroutine per, or a Go routine, not a Go routine per request, or else it's going to get, like if you halt it, then it's going to suck. But this type of test specifically targets server implementation of unbounded Go routines versus using a worker pool in Go. If you made a Go server that used worker pools, then it'd perform better in this case. I'm sure it would. I've never played around with worker pools in Go, so I have no idea. Right? This test is poop. Well, it's interesting in the sense that you can see that I think the most interesting takeaway I have about this is that smaller synthetic tests can produce wildly weird outcomes. And one should never take the synthetic test you see. Did you see the difference between these two? These two tests are not that much different, but you can see a vastly difference in performance. Think about how many times, especially if you're at like a larger company, where you have somebody come in and they show you something. And they're like, look at how much better this is. And so many people latch onto those things. And they go, see, this is better. And there's no actual real production traffic. There's no real production workload. There's no real anything about it. They showed something that is in their favor. Because what you could do, like honestly, how much do you think people will show this first test and be like, look, Bun is better? I bet you there are tweets right now that only watch this far into the test, and that's it, and people are talking about it, and that's that, and it's not even real, right? Like they're being misled for some dumb reason. Just be super careful. I think that's the big takeaway here is that slight variations can cause vastly different outcomes in these kind of micro benchmarky type environments.
MongoDB CPU usage, application CPU usage, memory usage, availability graph, and finally CPU throttling. I have other benchmarks that you might find interesting, and if you know how to improve any of these applications, please feel free to submit a pull request. Thank you for watching, and I'll see you in the next video.
So I did something, I think I call it like shooter.js, the Primogen. So I did something similar, and I did this one I did with various different ones, and I have a whole like view and everything that is involved in this, and I do a lot of fun stuff with this, and like the differences are significant. And then I even did one with Rust in here, and someone made a PR to Rust. Let's see if they have it in here. I don't think so. Anyways, no, it doesn't look like there is. Someone made a PR in Rust and showed me a different way to do it in Rust, and it made it just like insanely faster. And there's all sorts of kind of fun ways you can do stuff that you can do that it's just not really possible in the in the world, in the JavaScript world versus in these worlds where you can just go so much faster. And the basic testing I was doing was seeing how much like theoretical games that involve collision detection and everything on a server can I run concurrently and have good performance, meaning that frames aren't dropped on the server. And it's just like the difference between any node, any JavaScript versus Go is like 10x different. And any difference between Go and Rust is significantly different, but it is not different in the same level. Right? It's just better, but not by the same level of margin, right? And so it's interesting. It's just a very interesting world looking at these and seeing how people form these kind of marks. Big takeaway, don't trust micro benchmarks. Don't trust small world benchmarks. Trust real data. Go out, measure production. Go and make a change. Continue to measure production. Does production's 99 percentile go up or down? Because if it goes down, then guess what? Good thing happened. You probably solved some problems. You probably made better stuff. So test in production. Don't test synthetic tests. Don't make decisions based on really small synthetic tests. You'll likely be sad. Measure your production, not mine or anyone else. We have different products. Anyways, the name that was pretty interesting though. It's interesting that I feel nerd sniped, but I'm refusing to do it because all I want to do is finish up my stuff right here. My little, I'm building a simulation tester for my game servers, and so I want to finish that, so I'm refusing to let myself be nerd sniped, but I can feel it. I can feel the pull. I feel the pull of being nerd sniped right now. Just not doing it. Not letting it. Not going to let it happen again.